a super-mysterious celestial object, HH30. This is a young star system, about 450 light-years away from us, nestled in the Taurus molecular cloud. Why is it so mysterious? Because it's like a natural planetary nursery, allowing astronomers to watch planets being born up close. The Webb Space Telescope is really amazing. With a glance from its infrared eyes, the true face of HH30 was revealed. In the photos it took, a dark band of dust blocks the light of the young star. But above and below this band, the bright scattered light is incredibly dazzling. This means the dust disk is flattening, a crucial step in planet formation. And there's more. Narrow jets spewing from the system's poles, like a laser show in the cosmos. These jets are formed when material spirals towards the star, and some of the gas is thrown out. Looking at these energetic outbursts, scientists now have a much better understanding of the chaotic environment around young stars. Webb can also see through the dust, revealing temperature differences within the disk. The inner regions are denser with dust and have lower temperatures, which is a key booster for particles to stick together and grow bigger. These observations are like pieces of a puzzle, forming a super clear picture of a developing planetary system. In HH30, dust particles are gathering towards a dense midplane. This is the opening act of planet formation. These particles collide with each other, slowly growing larger, from clumps to pebbles, and finally into planetesimals. The cooling of the dust disk is a major contributor in this process. Larger particles dissipate heat faster, creating an excellent environment for particles to stick together. Another key factor is radial drift, where dust slowly moves towards the star. This determines where the planets will eventually settle down. Webb also found simple organic molecules, which is amazing. It suggests that the basic ingredients for life might be common in young planetary systems. The interaction between dust and the surrounding gas is also crucial. Gas affects the movement of dust, creating turbulence, which can either help or hinder planet formation. In HH30, Webb found areas with high dust accumulation, where it's easier for particles to stick together and grow into large solid bodies. This is a critical step in planet formation. HH30 is not the only one. There are other systems that also hold the secrets of planet formation. HL Tauri, a young star, has clear rings in its circumstellar disk, which are likely traces left by growing planets. Carving pads in the dust, the PDS-70 system is even more amazing, with directly imaged forming planets. These planets are growing by accreting material, like little cosmic foodies. Comparing these systems is like looking at a photo album of planetary growth at different stages, which helps us refine our models of planetary evolution. These discoveries are also a great help in the search for extraterrestrial life. The organic molecules in HH30 could be the key seeds of life. In the future, new instruments like the extremely large telescope belt will take over from Webb. To study these planetary cradles in more detail, the concentric rings in HL Tauri suggest that planets may have already emerged from the dust. It's a bit later in development than HH30, making it a great example for studying how young systems evolve. PDS-70, on the other hand, provides solid evidence of exoplanets in the process of formation. Astronomers have captured images of two large planets orbiting within the dust disk. This represents a later stage of planet formation, complementing the early processes seen in HH30. It's like watching a cosmic documentary on planetary growth. The organic molecules in HH30 are also intriguing. It's possible that many young star systems have the basic conditions for life. Studying these environments can help astronomers understand how many places in the universe are suitable for life. This is a very important question. Friends, today we explored HH30 together. From dust accumulation to potential regions of planet formation. These discoveries are like a window, allowing us to see how planets are born. This also helps us better understand how our own solar system came to be and what conditions are needed for habitable planets elsewhere in the universe. In the future, with the addition of new telescopes, we are one step closer to finding life elsewhere in the universe. There are so many mysteries in the universe. Let's continue to explore together.